All right. So this is the circle review sheet, kind of as putting all of the different tricks we've learned into one basket here. So let's go ahead and kind of work this through together. I'll walk through. I'm going to start on the side titled Mixture View. I know they both sides of this start with number 1. So I'm just choosing this side to start with. Okay, I'll work problem by problem. Feel free to fast forward to whatever problem you want, as I'll just go in order 1, 2, 3, and so on. Okay, and before we start, I just want to highlight that again, kind of the order that mentally I go through these problems is first, I look for, are there inscribed angles, right? Because that's A and 2A. Otherwise, do I have a full circle being 360 degrees or half a circle being 180, right? Then if neither of those work, and I check and check and recheck. The other thing I check too after that is it a random interior angle, right? Then you get that it's half of the two arcs added together. It's the average. And then the other thing I check, these are just the super common ones, is it that like spotlight shining at the circle again? And that's the x equals 1/2 the big minus the small arc. Okay, those are my kind of go-tos. There's lots of other smaller tricks, but those are the main ones I'm going to look at. And of course, not getting the inscribed angle mixed up with a central angle, right? A central angle, if this is A, then this is A. So not getting those mixed up. But all right, so I'm going to go through looking for those 4. So first one, oh yeah, I see my like spotlight going through the circle. So I'm just going to set this up and say x is 1/2 big arc minus small arc. So right away, this is 1/2 of 42 or 21. It just asks for x, so 21 degrees. Okay, on the next one, oh, again, I see the spotlight here. I'm not even going to look at what it's asking for. I'm going to use this spotlight to find this arc here, x. And then after I do that, I'm going to notice that I have a whole circle of 360 degrees. So once I know x, I can subtract x and 140 from 360, and I can find this last piece over here. And I just see that it's asking for arcs. I don't even know which arcs yet, but I'll just find them all. Okay, so off to the side, I'll just make this a little bigger. I'm going to say my angle outside is equal to 1/2 the big arc minus the small arc. So that's 35. Oh, rather than distributing the 1/2, I'm going to multiply by 2 on both sides. So actually, this isn't 35. This is 70 equals, and 2 times 1/2 cancels. We get 140 minus x. So adding x to both sides, subtracting 70 from both sides, we get x equals 70. So writing that in here, this is 70. And then if I want to find out the rest as a separate portion here, I'll take 360, subtract my 140, and subtract my 70. So that's 360 minus 210. That's 150 degrees, so 150. So up here it asks for CD. Again, it's always referring to the minor arc when it gives me just 2 letters. So this is 70 degrees. ED, it's referring to, again, the minor arc. 150 is less than 180. So there we go. All right, on to number 3. So number 3, let's look at this. Well, right away I see a whole circle is 360 degrees. So I'm just going to subtract this from 360 and get 114 over here. And before I go any further, I'm just going to say, well, I know this is 114 degrees too. Okay, because that's a central angle. On the other side, I know this is 246. Okay, so that's all my arcs and angles inside the circle. So let's see what it's looking for here. It's looking for arc CD. Oh, I've already got that. That's 114 degrees. And then angle DEC. So it wants to know this angle down here in the bottom. Okay, so there's a couple ways we could do this. Okay, I'll kind of just mention 2. One is, I have a radius and a tangent. Those must be perpendicular. Another radius and a tangent over here must be perpendicular. And a 4-sided figure must add up to 360 degrees. Specifically, this is a kite because we know the tangents are congruent. We know these are congruent. But any four-sided figure adds up to 360, so I could go 360 minus 90 minus 90 minus 114, and that would give me my angle. Or, using our four main things up here at the top, I'm going to see that, oh my gosh, this is just another one of those spotlight ones. So down here, I'm going to go ahead and say, totally separate from that, I'm going to say the angle I'm looking for, let's call it x, is equal to 1/2, the big one, minus the small one. So that's 1/2 of, that's 132, I believe. So that's 66, I believe. Doing the arithmetic in my head, I might have made a mistake there. There's 66. Perfect. And just double checking up here, 360 minus 90 minus 90, this would be 180 minus 114, and that would give us 66. So just double checking a second way we got the same result. So that's good. Okay, on to number 4. So looking at number 4, it doesn't appear to give us anything in the problem. So reading up here, CE is a tangent. Oh, that's good to know. And arc BC is 150 degrees. Great. BC referring obviously to the minor arc between these two. So right away, the rest of that then must be 360 minus that. So 210 is the rest of the circle. And then I also noticed that here is an inscribed angle opening up to that arc. So that's half of 150, or 75 degrees. And this is an inscribed angle opening up to this, or just the rest of 180 down here at the bottom. And so it must be half of 210, so it's 105 degrees. Right? 105 plus 75, that adds up to 180. So let's look what it's asking for. It's asking for angle BCE. So angle BCE, that's 75 degrees. Or arc BAC, so that's talking about the rest of the circle. That's 210 degrees. Okay, on to number 5 here. So number 5, right away I noticed this is two lines intersecting, not in the center. So I realized that this angle must be the average of these two on the side, right? And that's just my trick number 3 right up here. I identify that right away. So once I identify that, I say, okay, well then, the inside one equals 1/2 of the two outside ones added together, x plus 60. Rather than distribute in a half here, and I'm going to make my pen a little thinner. Rather than distribute in a half, I'll multiply by 2. So I have 140, this cancels, equals x plus 60. So minus 60 minus 60, we get 80 is equal to x. Okay, so once this is 80 degrees, we got 2 ways to go about this, right? We could either know that y must be the supplement, because there's a straight line there, so 180 minus 70, this must be 110. And then we could do the same thing. We could say, here I'll call this option 1, right? We could say, oh look, y, 110, is equal to the average of the two arcs, so that'd be z on one side plus 79 degrees on the other, right? Because y and y, just like how we solved for the first one, open up to 79 and z, and we could solve it that way. Or option 2, right? There's always so many choices here. Option 2 is we have a full circle is 360 degrees. So we could say 360 minus 80 minus 60 minus 79. Okay, so I'm going to go ahead and say this is 360 minus 140 minus 79. So that's 220 minus 79, and that's 141. Just to double check, I'll solve it with this other method too. So multiplying by 2, I get 220 equals z plus 79. Subtracting 79. Oh, I get the same thing over here, 220 minus 79. So that's 141. Okay, so looking up here, it asks for z, 141. It asks for y, which was 110. And it asks for x, which was 80 degrees. Okay. Number 6 says, oh, we got a lot going on here. Okay, so let's identify a couple things first. I got an intersection inside the circle, so that's equal to the average. I have an angle outside, which is 1/2 big arc minus small arc. I have an inscribed angle here. So we've got a lot going on, okay? Let's see if any one of these jumps out as something we could solve for right away. Right away, I see that this 39, and this is handy because this just happens to be trick number 1. And you could kind of riddle out each one and see which one will give you an answer, right? If I look at, just to highlight, if I look at this angle Z, it would be 1/2 of 60 plus this is the arc that Z opens up to. So we get Z equals 1/2 times 60 plus X plus Y. 3 variables in one equation. Let's not go with that one first. Okay, over here I could have this angle, which we don't even have a variable, so we'd have to call it something new, like A would equal 72 minus X. So okay, again, 2 variables here. Whereas this one would be 39 times 2 equals, and it would equal this arc. So now we've only got 1 variable. So I'm choosing that one to solve for first. Okay, so 39 times 2, right? That's the arc that opens up to, because that's the inscribed angle. So that's 78 is equal to 44 plus X, because it's that whole arc. So subtracting 44, subtracting 44, now we get that that's, let's see, that's 34. So we got that this is 34 degrees here. And now I've got all the arcs in my circle but one. So again, looking up here, I've used trick number 1, inscribed angle, and then I went straight to trick number 2. I've got 360 total or 180, and that's always the ones I want to use first if I can. Okay, so down here, Y, we're going to do 360 minus 72 minus 60 minus, and I know that 44 and 34 together is 78, because that's the inscribed angle we were just talking about, so I'll put that together. So 360 minus 60 is 300, minus 72 and 78 together is 150. So we get Y is 150. Okay, so this is 150 down here. So now that first relationship is looking pretty good, because now we've got this relationship. Again, I'm not solving for this one only because it doesn't have a variable. It's not asking for this one. But now we have Z is equal to 1/2 the top arc plus the bottom arc, and now we know X and Y. So those are known numbers now. So I'm going to go off to the side here, create a little space for myself, and I'm going to say Z equals 1/2 of one arc, which is 60, plus the other arc, and the other arc that Z opens up to here is this whole thing here. So that'd be 150 plus 34 on that side. So sorry, my writing's a little sloppy over here. So 1/2 of, and then 60 plus 150, that's 210, plus 34, so that's 1/2 of 244. Those are nice, easy numbers, so that's 122 degrees. Okay, so going up here, Z was 122 degrees, Y was 150 degrees, and X was 34 degrees. Okay, number 7. A, B, and AC are tangents, okay? So again, I notice a lot of things here, okay? I notice I've got an inscribed angle opening up. Oh, right away I could get Y. Let's do that. Okay, I've got Z opening up to 2 arcs. I've got one arc, which is 127, and the other arc, which is X and Y, and I don't know both X and Y yet. But let's just stick with our first trick and our second trick. Inscribed angle first trick, second trick, half a circle. Okay, so let's go with that. So first trick, we multiply by 2. We get that Y is 68 degrees. Second trick, I see this, and that's 180 degrees. And so I know I can subtract 68 from 180, and I get 112 here. Now that relationship we identified out here comes in useful. We've got, oh, and I could even complete this circle. Let's go ahead and add in this last little arc over here. Again, if I've got 180 on both sides, that 127 subtracted from 180 on the top, we get 53 degrees is this arc. Okay, so now that we've got all the arcs in the circle here, this exterior angle Z is equal to half of the difference between the small arc and the big arc. Okay, so off to the side here, I'll say Z equals 1/2. The big one, which I haven't added them up yet, but that's 53 degrees plus 68 plus 112, all minus the small one, 127. Right? And whatever you get here should just be the rest of the circle from 127, should just be the 360 degrees. Okay? So let's see, this is 1/2 of, we get, adding these together, this was 180, a half a circle plus that 53. So that's 233. So 1/2 of 233. Oh, it's not going to work out nicely, but that's okay. So we get 116.5. So that's Z, 116.5. X was 112. And Y was 68 degrees. Okay, let's go over here now to 8. 8 says AB is tangent, and the measure of ABC is 75. So ABC, this is 75 degrees right here. Okay, so let's start. Well, right away I see an inscribed angle. The 75 degrees times 2 opens up to a 150 degree arc. And now my second trick, right after inscribed angles, trick number 2, we got 360 degrees, so we can find X. And so we say X is equal to 360 minus 85 minus 97 minus 150. I'll say these two, that gives me 210 minus, just putting these two together, that would be minus 182. So we end up getting that is 28, I believe. Okay, so here's 28 degrees for X. And now how would I get Y? Well, I identify Y as an exterior angle out here floating outside the circle. So I know the only way to get that, not the only way, there's multiple ways, but we can get Y equals 1/2 the big arc. So the big arc over here is 97. The small arc is 28. So 1/2 of 97 minus 28. Okay, 1/2 of, that ends up being taking 27 away. We're at 70, so that's 1/2 of 69. So that ends up being 34.5. So Y is 34.5. X is 28. Okay, so that's one side. Let's move on to the second side now. Okay, looking at this. Again, I'm just going with, like, you're starting to hopefully notice a pattern. When I can, I use inscribed angles. Then I go to my 360 or half is 180. And as soon as I've used these up, as much as I possibly can, that's when I check for it. Well, do I have an odd angle inside the circle or an odd angle outside the circle? And that's exactly how I solved the last two. I went inscribed angle, then 360 degrees, and then, okay, I've used that all up, and look, I've got an exterior angle. Over here, I did the same thing, right? I said, I've got an inscribed angle, then I've got a 180 and a 180, maybe even some 360, and finally an angle outside. So let's do that here. Look, I've got an inscribed angle, so this must be half of it, 40. I now know, too, that this is half a circle. This is 180 degrees, so the leftover must be 100, because I just take from half the circle. So now that already gives me a lot. And over here it tells me XM is 80. Oh, we already had that. So let's look. The measure of angle XNM we already got was 40 degrees. That was the first thing. The measure of arc XN, so from here to here, that's 180. We can tell because it goes through this center point. So 180 degrees. And the measure of arc NM or MN, that's 100 degrees because it's the other portion. Okay, number 2 here, AB is a tangent. So AB is tangent down there at the bottom. All right, let's look. Oh my gosh, look at this. Inscribed angle, so times 2, Z is equal to 120. We don't know this angle inside yet, but look at this. It's the inscribed angle of 120. So half of 120 is 60. So that means the other portion of this angle here, y, must be subtracting from 180. You get 180 minus 60 minus 60. We get a leftover of 60 degrees. We could have also seen that this total is 360, and the leftover over here is 120. Dividing it by 2, we get 60. And of course, then what's x? And I'll tell you the common mistake is people say, oh, it's an inscribed angle. It's half of 120. But the inscribed angle is when the point is on the edge, the outside of the circle. That's a central angle. So that's just saying what chunk out of 360 degrees is that portion. That portion is exactly 120 degrees. So the interior angle, remember, is equal to the measure of the arc. So 120 degrees for x. Z was 120 degrees, and y was 60 degrees. Okay, on to number 3. So number 3, right away I say, okay, I've got some stuff here. Look at this. I've got number 1 trick, inscribed angle. I got C is 35 degrees. Okay. Trick number 2, I say, oh my gosh, look at this. I got 180 degrees right here, cutting my circle in half. 180 over here, 180 on the other side, which leaves me with 110. And then we're back to trick number 1, inscribed angles, right? Inscribed angle of 110 is 55. And inscribed angle of 180 is 90. Oh my goodness, just our 2 favorite tricks, right? That's all we use. So A is 90 degrees, B is 55 degrees, and C is 35 degrees. Okay, over here, oh my goodness, just our bread and butter tricks, right? We got inscribed angle is half of 140, that's 70. Inscribed angle of 100, that's 50 degrees. And then we've got, oh, what's this portion over here? The rest of a full circle. So 360 minus 140 minus 100, that's 260, using the 100 up, minus 140. So that's 120 is left over here. And then the inscribed angle of 120 is 60. So A is 50, B is 60, and C is 70. Oh my goodness, I love those tricks, okay? So down here, these are tangents, okay? So again, you got 2 ways to approach this. I really like this style. When you've got a radius and a tangent, we know those are right angles. So we could say, well, 4-sided figure. Again, it's specifically, it's a kite. But any 4-sided figure, we could say 360 minus the 90 minus the 90 minus the 40, and get that that's 180 minus 40, or this is 140 degrees. The other way to solve this is a little more difficult algebraically. We could say, well, let's find out what this arc measure is. Well, if the central angle here is x, well, then this is also x right here. And the rest of the circle then would be 360 minus x. And now this leaves me with an exterior angle, which I know the relationship for. An exterior angle is equal to 1/2 the big arc. That's 360 minus x, right? And then minus the small arc. So 1/2 big minus small, and then just a little algebra, 40 equals 1/2 360 minus 2x, distributing that in, 40 equals 180 minus x, adding x to both sides, subtracting 40 from both sides, we get that x equals 140. So same thing either way. Groovy. Okay, over here. AD is tangent. Okay, so let's start here. If AD is tangent, we know this is 90. We notice right away we've got a diameter. So we've got 180 degrees over here. We don't know what we've got here. And again, there's no like automatic inscribed angle of multiply this by 2 or something. This is an exterior angle. So let's off to the side say, okay, well that means 54 degrees is equal to 1/2 the big arc. The big arc in this case, it opens up to 180 degrees. That's where it crosses here and it crosses here. So the big arc is 180. So 1/2 of 180 minus the small arc. And the small arc, I don't know, let's call A, okay? So 180 minus A. So since that doesn't distribute it nicely, let's multiply both sides by 2. We get 108 equals, canceling that, 180 minus a, so adding a to both sides, subtracting 108 from both sides, we get a equals 72. So here's 72 degrees. Finding the last couple things I can in this. We got, oh my goodness, we could have just done it with our bread and butter. I didn't notice it. In a different color, we have a right triangle with a 90-degree angle, a 54-degree angle. So subtracting all that from 180, we get that this is not 40. We get that this is 36 degrees. 36 times 2, 72. That was a much easier way. What the heck? Okay, that's okay. There are always shortcuts. So now once we have that 72 through either method, we could say subtracting from 180, we get that the rest of the circle over here is 108. So that looks like we found everything in the picture. Let's go over and see what it was asking for. The measure of angle A, of course, that's 90 degrees. The measure of arc AB, referring to the short minor arc, that's 72 degrees. The measure of angle C is 36 degrees. The measure of arc BC is 108 degrees. Great, that was a cool problem, okay? So over here, we've got just a bunch of inscribed angles and a triangle. What am I, let's just do it in pink. I like pink, okay? So subtracting from 180, we get that the missing angle in this triangle is 30 degrees. And now it's just inscribed angles. So times 2, this arc is 60, times 2, this arc is 140, times 2, we get this is 160. Just double checking when you add those together, they add up to 360. Nice, didn't make a mistake there. Okay, so let's go over here and see what it's asking for. Arc AD, of course that's the less than 180 version, so that's 140 degrees. Measure of angle D, 30 degrees. Arc AB, that's 60 degrees. And DAB, now it's a go from D to B, but go through the point A. So that would be the 140 plus the 60. So that would be 200 degrees. Notice they had to use a third point to label an arc that was more than 180. Because if they just said the measure of arc DB, they'd be referring to the less than 180 minor arc. So we would have said, oh, that's 160 degrees correctly. But they asked for the other direction. So they said go from D to B, but go through point A, referring to the major arc. All right, so over here, let's look at a couple things. Well, first of all, vertical angles. I know this is 87. I could subtract from 180, and I could say, okay, that's 116. Subtracting from 180, I get the last angle 64. Okay, down here in this triangle, well, I mean, so one thing you could notice, you don't have to, is that if one angle opens up to this arc here, and another angle opens up to the same arc, it must be the same angle. You don't need to notice that, but that's nice to notice. Same thing about the 64 here, opening up to arc P. Well, then this must be 64 too. Now, if you didn't notice that, totally okay. Let's actually, you know what? Let's actually erase all this and do it again, not noticing that cool trick, okay? So we just notice a vertical angle and a triangle is 180, so we got 64. Now let's just go with our bread and butter. Inscribed angle, this is 64 times 2, 128. Bread and butter, 29 times 2 is 58 degrees, okay? Now we just got to find out S and Q here, okay? Now, without any extra information, all we would know is that 87 is the average of the two. But we couldn't figure out what S and Q are because one could be big, one could be small, like they could be around equal, the other one could be big or small. So there would be an infinite number of solutions here just knowing that 87 is the average of two numbers. There's an infinite number of pairs of numbers that solve that. However, that additional piece of information here is that the chords are congruent. And this is something we hadn't used so far. So when the chords are congruent, that means the arcs are congruent. So what I'm going to go ahead and do is I'm going to go ahead and cross out Q and call this one S for now, because I know these two things are the same. I know S and Q are the same arc since their chords are the same. So now, rather than doing that 87 is the average, you could. 87 is the average of S and S, right? But if they're the same, it would just come out to be that S is 87. Because, right, if 87 is the average of two numbers and the two numbers are the same, well, the average of two equal numbers is that number. So right away, we could do that and say, okay, S is 87. But rather than go with that way, I'm going to go with my easy plan of these add up to 360. And again, you're allowed a calculator here. So all you do is off to the side, go 360 minus 128 minus 58. And that's equal to the two S's, because there's two S arcs, right? I'm saying it's equal to this and this that's left over. So we get that that's 360 minus, that's 170, 186. Okay, so taking that away, we get that that's 200, that's whoa, mentally this is hard, 174, I believe. Yeah, okay, equals 2S. Dividing that by 2 on both sides, I get that S is, no surprise, it's equal to 87. Because, right, if 87 is the average of two equal things, it had to be 87 in the first place. So S and Q are both 87 degrees. R was 58 degrees, and P is 128 degrees. Okay, let's go over here to, this is the last one. Okay, this is a big one. Okay, let's see if I can zoom in at all here. Come on, let me get a little bigger. Whoa, that's big. Okay, that's as big as we get. So, take a deep breath. It's a little, kind of looks like a dream weaver here. There's a lot going on. So let's piece by piece start with the easy strategies, okay? I see a 25 here is an inscribed angle, so I know this arc is 50, okay? And I'm not going to label huge arcs if I can avoid it. I want single pieces of arcs, because later on then I could add them together rather than this one overlaps with that one. I don't want to say like, well, this one's 130 and this one over here is something else and this one over. I want to find piece by piece. So I know that one's 50, okay? And look at this. This one opens up to an arc from, and I'll erase this, but from here to here, that is an arc of 2 times 50 or 100. So I take away the 50 I know, and I get that this smaller arc here is 50. Okay, so I'm just going to erase those really quick. And so this arc is 50 degrees. Okay, so we've got those two arcs are 50. Now, I notice a diameter here. So this diameter here says that the bottom half, or the bottom right half, is 180, and I already have a 50 and a 50, so my leftover portion here must be 80 degrees. Okay, cool. All right, so let's see what else. And I could fill out all these central angles. If I know that's 50, then this is 50, then this is 50, then this is 80. Awesome, okay. So looking around, I got a couple other things. What do I notice? I know D and E must add up to 180 degrees. Let's see, what do we have? Well, one thing we haven't used here yet is the fact that, I'll highlight it in pink, we have two parallel lines here cutting through this. Now, there are some cool things that we have not discussed about parallel lines and how they relate to circles. So let's not go with more advanced implications going through. Let's go with the basics. If we know there are parallel lines, the main thing we know about parallel lines is the two intersections are the same, right? Vertical angles, we already knew these are the same. But the big idea is, if the two lines are parallel, well, then those two angles down here must be exactly the same, because the angle in which the transversal cuts them is the same. And the most common way we refer to that is either that alternate interior angles are congruent or that corresponding angles are congruent. In this case, we notice that alternate interior angles are congruent. So we get that this is 50 degrees, and a central angle of 50 degrees opens up to an arc of 50 degrees. That leaves me with, on this side of the circle, 180 minus 50. So that is 130 degrees. Okay, so we seem to, oh, and that gives me a central angle of 130. That seems to be most of the things. We got all of the arcs. We got all of the central angles. Let's see what we're missing, okay? Oh, so over here, K is just the inscribed angle of this arc 80. So this is just 40. I love inscribed angles. Okay. And then J and F, well, I don't know if it gives us to us in writing, but let's see if it does give it to us in writing. Yeah. It says AT and AZ are tangents. And so we know that this right here is a tangent to a radius. And this right here is a tangent to a radius. And so right away we know that this angle here must be 90. And this angle here must be 90. And I think that's all. I'm going to go ahead and start filling these in just to see if we missed any. So C was 80 degrees. F was, oh my goodness, finding all this. F was 90 degrees. J was 90 degrees. N was 50 degrees. M was 80 degrees. H was 50. E 130. B, oh, where's B? 50. Let's see if we got them all. So A is 50. D is 50. G was 50. And K was 40. So we did find them all. Now, absolutely, there were so many different ways to approach this problem. Don't think that the one way I did it is correct. I showed you one avenue into this problem, okay? The way I approached it was from central angles and all the arcs adding up to 180 and half the circle, adding up to 360 and half the circle being 180. That's how I approached it. You could approach it in any way you want, okay? Hopefully that was helpful. If not, you didn't have to watch the video. But yeah, I hope you enjoyed it. Yeah, good luck.